And with that, we are ready to move to our next presenter. We are so excited to have Leon Anavi. Hey, Leon, how are you doing?
Hi, everybody. It's great to be here. How are you?
It's great to have you. We're good. How's everything going over there?
It's a bit of a rainy afternoon, but
Mhm.
everything is fine.
We're in completely different
Yeah.
set. It is so
It's
hot here
it's
today.
weirdly warm here.
So,
Anytime is good for open source hardware, right?
It's true.
exactly. So, what have you been working on?
Let me see how can I share the slides. I've uploaded them.
Oh,
Oh, okay,
there we
that's
go.
fantastic. So I've been working on a few new open source hardware add-on boards for Raspberry Pi, but actually I wanted to share with all the viewers my story, how I got excited about open source hardware. I'm a software developer. I'm not a hardware engineer. I've graduated from the technical university, but all my life I have been focused on software. Even as of the moment, my full-time job is as a software engineer. However, because I'm passionate about open source software, it was a natural choice for me to give open source hardware a try. And of course, I know that for many people excited about open source, it's the same way. However, there's a lot of practical reasons why to choose open source hardware. It keeps the prices low and fair. It allows users to have a look at the schematics and repair their devices even after the warranty period. And it also enables people to share knowledge and ideas. So you can either commercially integrate open source hardware um, within your devices, and of course you can get feedback from the community, so other people can improve the designs and make it better. Um, a lot of people claim to make open source hardware. This is where the Open Source Hardware Associations comes into play, and I really like the Open Source Hardware Certification Program because this way you can be sure that the device that has been certified actually complies with the community rules and expectations for what open source hardware is. And the bonus is that you get a unique ID for the certified hardware based on the country. I live in Plovdiv, Bulgaria, so all the products that I have certified through the Open Source Hardware Association certification program start with a prefix BG. Uh, Something that's really important for me is the question, does it make sense to use proprietary software for open source hardware? I know that there are a lot of great um, CAD tools, software tools to design multi-layer printed circuit boards with a lot of great features. But can you build a sustainable community if your contributors are supposed to pay licenses fees for the software to design the hardware? And my answer is straightforward and simple: no. If you're developing open source hardware, in my opinion, you should be using free and open source software. Um, of course, open source hardware is not just the printed circuit board or the case. It's a combination of hardware, software, and last but not least, documentation. It's very important to provide users documentation. This way, the community can grow, people can get started fast, understand how things work, and move on forward. And in terms of software for designing hardware, there are great open source options such as KiCad. Um, I got involved into KiCad thanks to Olimex and Svetlana Zunov, who is also from Plovdiv, and he'll be among the next speakers. Several years ago, his company Olimex moved to KiCad, and they were kind enough to make workshops for the local community here in Bulgaria so that other people can get started with KiCad. And that's how I got involved. Thanks to him and friends for helping me out to get started with KiCad, I made my first add-on board for Raspberry Pi. This is the infrared FAT that you can plug on any Raspberry Pi single board computer with 40-pin header. to scan remote controls and send infrared signals. I had a talk about it many years ago at FOSDEM. FOSDEM is a huge free and open source software conference happening in Brussels. The next edition will be at the end of January, beginning of February 2026. And FOSDEM stands for Free and Open Source Developer European Meeting. But nowadays, there are a lot of people coming from all around the world. So if you are interested in open source software or hardware, and I'm sure that the people watching the stream are, consider joining the next edition of FOSDEM. It's a really great event. And above all, it's a free event, so you don't need to register or do anything. You just show up and get together with the other people. So the board that I would like you to show, it's something that I designed this year. It's a TPM20 Atom board for Raspberry Pi. I wanted to make a small user-friendly Atom board for Raspberry Pi single board computers built around a chip that supports TPM20 because out of the box Raspberry Pi single board computers does not have such. This is not the first board available. There are commercially available boards that have the same purpose, and they're really good boards. However, they're not open source hardware. So the major driving force for me to design this board was, of course, to make it as open source hardware. It is designed with KiCad because, as I told you, in my opinion, it only makes sense to design open source hardware with free and open source software. The good thing about KiCad is that it runs on different operating systems. You can use it on Mac OS, on Microsoft Windows, or, as in my case, on Linux distributions. I personally use KiCad on Ubuntu Linux. So the board that I've designed, it's really tiny, very simple board. The bill of materials, as you can see, is just 8 components. So it's a really, really simple two-layer printed circuit board. It connects over the serial peripheral interface, which is available as part of the 40-pin header of Raspberry Pis. The difference compared to the existing other TPM boards for Raspberry Pi is that it supports through-hole connectors. So we have the opportunity to either use a horizontal or vertical connector. So we can have a vertical mount of this board. And this is really convenient for Raspberry Pi 5 if we want to use it with the active cooler, which is actually a heatsink and a fan, which mechanically allows to have no conflicts between the vertical mount of this Atom board and the cooler. The typical use cases for the TPM20 on Raspberry Pi 5 and previous Raspberry Pi modules are disk encryption, device authentication, digital signature, measured boot, and random number generator, because the chip that I've selected actually supports random number generator as well. The chip is Infineon Optiga SLB9672. This is a well-known in the industry TPM20 chip. That's why I've selected it. There is already an existing device tree binary overlay for the Raspberry Pi, which means that as part of the kernel, you can build the device tree binary overlay. It's available as part of the Raspberry Pi OS as well. And by loading this TPM from the software side, you can easily enable the hardware and use it. Because of this, Anavi TPM20 Atom board works with all Raspberry Pi single board computers. And I've also added a really, really tiny hole for physical attachment. The dimensions are small, but not super small. When I was designing the board, I wanted to make sure that the size allows even hand soldering the components. And for the resistors and capacitors, that's easy. For the Optiga SLB chip, not so easy, but possible. So the hardware license is Creative Commons Share Alike 4.0 version. I've certified it with the UID BG152. I have to say that we have a lot of certified open source hardware boards from Bulgaria. kudos to Drew Fustini, who maybe, I don't know, 6 or 7 years ago told me about the certification program of the Open Source Hardware Association. I decided to give it a try. I really enjoy the whole idea. And that's how I started certifying the open source hardware gadgets that I'm doing. All schematics, actually the whole KiCad project is available in GitHub. Here is the link. Here is actually a screenshot from a YouTube video. I made a YouTube video to explain the whole process, how to make the board. The very first prototype was made at PCBWay. After that, I made boards and assembled them here in a factory, local factory in Plovdiv, Bulgaria. But for the prototype, I did hand soldering of the prototype. It wasn't easy, but I got it to work. Fortunately, the first revision failed because I forgot to connect one of the power pins on the Optiga SOB chip, but revision 1.1 is fine. So the tricky part here is manually soldering the very small chip for the Optiga. But once the prototype was ready, the next thing was to make a panel with a stencil, and things worked out really well after that. So one of the important things that I want to mention is that with software, improvements are straightforward and easy. People open, for example, a GitHub pull request for a project that's hosted in GitHub, contribute their changes, the maintainer review them, merge them, and with the next software release, you have this change, a bug fix or a new feature part of the product. With hardware, it's not that easy. However, we can still reuse some of the knowledge that we have from the open source software workflows for contribution, even to hardware. It's a bit tricky, of course, because someone has to manufacture the new hardware, test it, and then make a release. So sometimes people, instead of opening a GitHub pull request for hardware modification, they just open an issue and provide an idea. And based on this idea, the creator or the maintainer of the open source hardware project can do a modification. When something like this happens, it's a good practice to add a note to give credit to the person or the people involved in the modification. For example, Git has this feature for trailers where you can mention suggested by and the user who mentioned it. And I always like to give real world examples. So here are a couple of screenshots of things that have been contributed by community members to open source hardware boards that I have created through the years. As you can see, one of these commits is 7 years old. The other one is more recent, 3 years old. But these things work. They have been tried out. So I highly encourage hardware engineers to reuse the things that we know that work well from the software world in terms of contribution and interaction with the community. And pretty much this is the end of my presentation. So huge shout out to the Open Source Hardware Association for maintaining the certification program. It's fantastic to the things that you do, and the way that people can actually see what's really open source hardware, not just the PDF shared somewhere. As I mentioned, in my opinion, it's very important to have accessible design tools. That's why I'm using KiCad, because it's free and open source software. So anyone can install it on his computer and modify the designs that I have. And just as a tip, it's nice to have proven development workflows. This is the reason why I share all my projects in GitHub. Yeah, I know that for a lot of hardcore open source enthusiasts, GitLab would be a better choice. However, the GitHub ecosystem and the GitHub pull requests are very popular. A lot of people have GitHub profiles, and because of this, for me, it makes more sense, at least for the moment, to keep all my open source hardware projects in GitHub. And remember that community always matters. In terms of what's next, I've showed you a TPM board that connects over serial peripheral interface SPI to the Raspberry Pi, but actually Infineon also has another chip called SOB9673, which can be connected over I2C. So my next challenge in terms of open source hardware and TPM is to design a board that connects over the I2C and works with Raspberry Pi. Now, here it's probably something important to be said. I mentioned that Raspberry Pi doesn't have a built-in TPM, and when we're attaching this add-on board to the pins exposed on the 40-pin header of the Raspberry Pi, there is always some risk of hardware man-in-the-middle attack, so someone can start sniffing the communication. So it's not 100% sure. Keep this in mind, of course. Because of that, I have this tiny hole as part of the PCB, so you can, you can think of a mechanical way how to further secure your Raspberry Pi device with a TPM. And on the last slide, I've got a few links, useful links, how to get started. I hope that more people will become members of the Open Source Hardware Association. I've been a member for many years now. If you are creating something that's open source, I highly encourage you to certify it. I also highly encourage you to use KiCad as a free and open source software tool. And for the next step for this small add-on board that I've showed you, I'm working with the crowd supply team, and hopefully soon we'll kick off a crowdfunding campaign so that we can manufacture locally more boards and ship them to people interested in this project.
Amazing. Thank you so much, Leon. It's so cool to hear what you've been up to. And I love that you're being so thorough in your documentation and being able to help folks find the tools that they need to make their own projects.
And we'll definitely keep an eye out for your crowd supply campaign, and we'll be helping share that once it happens. So let us know.
Thank you.